Hello everyone. Today we're going to focus on the heating curve of water. I'm also going to make reference to the kinetic theory. What I'm going to do is to break this lesson into 3 parts by looking at some principles. Then I'm going to do some demonstrations. Then we take a look at the graphs. Now let's jump into the principles. The first principle I want to make note of is that particles are always in constant random motion, which simply means particles are always moving. The second principle that I want to make mention to is that kinetic energy is proportional to temperature, which simply means if temperature should increase, the kinetic energy will also increase. Likewise, if temperature remains the same, therefore, there will be no change in kinetic energy. Now, the third principle I want to make mention to is that a loss in kinetic energy results in a gain in potential energy. Now, the other principle will be very important for us to understand the concept. Now, as particles gain kinetic energy, they move faster, then eventually break away from each other when a certain temperature is reached. So what this means, that a substance may change phase or state only when a certain temperature is reached. Now, the final principle I want to make mention to now is that temperature remains the same during a change of phase. So once a substance is changing state or phase, there will be no temperature change. Now let's look at some demonstration. Now think about particles moving constantly and randomly. Now if I should crank up the temperature on the temperature scale, now what will happen here now is that the particles will start to behave differently. So notice the particles start to move faster because as temperature increases, there is an increase in the kinetic energy. Now let's think about a block of ice. Now let's take this ice to be negative 10 degrees Celsius. Now if I should apply some heat to this ice, what will happen? It will change to a new temperature. But notice there is no change in state. Because remember, once temperature changes, there will be no change in state. Hence, we still have a solid. Now, but what if I continue to apply some heat to this ice now at 0 degrees Celsius? Now, what will happen here is that the ice will eventually start to melt. But please note, there is no change in temperature. So from this, we can now state 2 things. Is that 1, the solid will turn into liquid. Also, because there is no temperature change, we can also note that the melting point of water is the same as the freezing point. So the liquid water that comes from the ice is the same temperature as ice. Now, what if we take this 0 degrees Celsius liquid water and start to apply a range of temperature or apply heat onto it? What you'll notice here, this temperature range, a matter of fact, is just some examples. We could have smaller intervals. So what we'll notice is that the temperature will get hot or heated over a range. Now, what is interesting is that when it reaches 100 degrees Celsius, then the water starts to boil. What is the conclusion here? Notice we have a change of what? Temperature, but the phase is not changing. So here we still have a liquid. Now, what if we take that 100 degrees Celsius liquid water and apply heat to it? Now, what will happen here is that the water will start to give off steam, which is gas. So notice here again, the temperature is not changing, but there is a change of phase. And so what we can make note of is that the boiling point is equal to the temperature at which water evaporates. And so hence we have liquid turns into gas. Now let's look at the graph. Let's look at our same ice at negative 10 degrees Celsius. Again, it will move to a change in temperature to 0 degrees Celsius, but also remember that this is still a solid. So the only thing is happening is that the solid water is being heated. In other words, ice is being heated. After 0 degrees Celsius, what will happen here is that we know since there is a change in temperature, therefore there must be a change in kinetic energy. Temperature increases, kinetic energy will also increase. Now let's look at the next thing that will happen here. This temperature will be maintained, which therefore means there is a change of phase. What process is taking place here is called melting. So therefore the solid will move into liquid. And again, temperature and kinetic energy remain the same. Now after 0 degrees Celsius, then there will be a change in temperature from 0 degrees Celsius to 100 degrees Celsius. What is happening here is that it is still a liquid, but the liquid is being heated. Very important to note is that temperature and kinetic energy, they both remain there. There will be an increase because once there's an increase in temperature, there is an increase in the kinetic energy. Now, after 100 degrees Celsius, now what will happen here, this temperature will be maintained, but importantly, this process is called boiling. And this is where liquid will turn into gas. And so again, temperature and kinetic energy remains the same because once the temperature is not changing, the kinetic energy will not change. Now, importantly, you could still continue to apply heat to this, so there will be a gradual increase in temperature, and so therefore the gas will be heated, so steam could get hotter and hotter. All right, and so this is a graphical representation. So let us now quickly put them together and see the overall process. So again, 0 degrees Celsius will be maintained, and that is called melting solid to liquid. And then we move from 0 degrees Celsius into 100 degrees Celsius, liquid. There's no change of state, but there's a change in temperature and also kinetic energy. For boiling, liquid is turned to gas. There's no change in temperature, hence there's no change in the kinetic energy. All right, and once gas is being heated, there's a change in temperature, hence there is a change in kinetic energy, which means the gas molecules will move much faster. This is where we end today, and so I want to tell you that I truly appreciate you watching these lessons, and I also want you to absorb positive energy. Be safe and take care.